In this video, we're going to take a closer look at the probability formula that you get in the formula booklet. There are actually 6 formulas that you are given in the formula booklet. The first one, the probability of an event A. So the probability of A is equal to the number in A over the number in the universal set. Well, if I draw a Venn diagram, and I've just got 1, and I know there are 12 people in there, and there are another 8 outside. I can work out that the probability of a person being in A is equal to the 12 people in A over the total number of people in the universal set, which is 12 plus 8. So the probability of A is 12 out of 20, which is equal to 6 out of 10, which is equal to 3/5. The second of the formulas is to do with complementary events. Well, if we look at the diagram again, we are either in A or not in A. So those two events must happen. I'm either in A or not in A. So the probability of A plus the probability of not in A must equal 1. Or the probability of the complement, not A, is equal to 1 minus the probability of event A. The third of the formulas is to do with combined events. It states that the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. So if we draw a Venn diagram with two events, A and B, the union is all of this section here. But that is equal to the probability of A plus the probability of B minus the intersection, because when you add the probability of A and the probability of B, you've actually counted the intersection twice. So, because the intersection has been counted twice, we have to take it away from the probability of A and the probability of B. The fourth formula is to do with mutually exclusive events. Well, mutually exclusive events have no intersection. So if we draw a Venn diagram, it will look like this, A and B. So that in this case, the probability of A union B is equal to the probability of A plus the probability of B. In this case, we don't have to subtract the intersection because there isn't one. The fifth formula is to do with conditional probability, and it states the probability of A given B is equal to the probability of A intersection B divided by the probability of B. Let's draw a Venn diagram to illustrate this formula. So here's my Venn diagram. It's to do with people liking apples and bananas. So apples, bananas. I know that 5 people just like apples. I know that 3 people like both apples and bananas, and I know that 7 people just like bananas. and 5 people like neither apples or bananas. And I want to know, what is the probability of somebody liking apples knowing that they already like bananas? Well, I already know they like bananas, so that reduces my sample size. My sample size now is just bananas. And I want to know, what is the probability that they like apples knowing that they like bananas? Well, that is the intersection, the probability of A intersection B. So in this case, it is 3 out of 10. The sixth of the probability formulas is to do with independent events, and it states that the probability of A intersection B is equal to the probability of A times the probability of B. Well, independent events are events that do not affect each other. For instance, if I flick a coin twice, the probability of getting a head both times is exactly the same. The probability of getting a head the second time does not change because I got a head the first time. So the probability of head and head is equal to the probability of head times the probability of head. If I had two different events, like tossing a coin and rolling a dice, and I want to know the probability of tail and a 6, well, that is equal to the probability of a tail times the probability of a 6. The two events are totally independent of each other.